Another technique we have to kind of narrow down what our zeros can be, or where our zeros can be, for a polynomial is Descartes' Rule of Signs. And this is where we look at a polynomial and we're specifically counting how many times the signs of our coefficients change when we have our polynomial written in standard form. So from our highest power of x down to our lowest power of x. So the number of positive real zeros of p of x has the same parity as, meaning even or odd, and does not exceed the number of variations in sign in p of x. Okay, so let's look at just here at this example at what that means. So we go through here and say, well, I just see if my my coefficients change between positive and negative. So here, from 3 to 4, those are both positive, there's no change. From 4 to 3, there's no change. But then 3 to -1, that changed signs. Okay, that's a variation in sign. So I would say, okay, there's a change in sign. Okay, but then from this -1 to -3, there's no change either. So there's one change in sign. So we would write that one change, or one variation in sign. Variation in sign. That's not how you spell sign. Sign. Okay. In p of x. Okay. So this Descartes' rule of signs says that the number of positive real zeros has the same parity. So this is an odd number. Okay, so we have an odd number of positive real zeros, and does not exceed the number of variations in sign. So we can't have more than one. Well, the only odd number that does not exceed 1 is 1, okay? Because we can only have positive numbers here. We can't, the number of positive real zeros that we have is either 0, 1, 2, 3, 4, right? We can't go to negatives there. So that means that we have precisely one positive real zero. The next part is the number of negative real zeros of p of x comes down to the number of variations of sign in p of negative x. So now we're going to look at p of negative x. P of negative x. So we plug negative x into this. Okay, 3 times negative x to the 6 plus 4 times negative x to the 5 plus 3 times negative x cubed minus negative x minus 3. And then we want to simplify this, and a negative to an even just disappears. So this is 3x to the 6, but a negative to an odd will actually come out. So this is now minus 4x to the 5. Here we have a negative to an odd, so it comes out minus 3x to the 3. Here we have a negative, so that's positive, and then our minus 3. So to know the number of negative real zeros, we look at the variations in sign. So from a positive 3 to a negative 4, that is one change. From negative 4 to negative 3, that doesn't change signs. From negative 3 to positive 1, that's a change. And from positive 1 to negative 3, that's a change. So I have here 3 changes, or 3 variations, in sign in p of negative x. Okay? So Descartes' rule of signs says the number of negative real zeros has the same parity as that. So odd, okay, we have an odd number of negative zeros, and does not exceed 3. So we don't have more than 3 negative real zeros. So the only odd numbers that don't exceed 3 are 1 and 3. Okay? Again, we can only have a positive number of negative real zeros. So there's either 1 or 3. Either 1 or 3 negative real zeros. Okay? And a reminder, up here we had 1 change into positive, so there was exactly 1. Exactly 1 positive real zero. Now, the reason this is helpful is because if you were, say, using the rational zeros theorem and trying to find the zeros of this polynomial, we would be testing a lot of different things. But once we find a positive number that works, that is a zero, we know we don't need to try any more positive zeros because there's only one. Okay? And likewise, if we have found two negative real zeros, we know that we need to keep going to get 3. And once we've gotten 3, we know that we're done. Okay? Now, what's interesting here is we know that the degree of a polynomial is the maximum number of zeros that we could possibly have, okay, for real zeros, for polynomials. So just looking at this polynomial, we know, well, I can have at most 6 zeros here. But from Descartes' rule of signs, I know that actually I can't have any more than 4. So if I were to find 4, I would know that I'm done, and the other 2 could not be real zeros, okay?